In this video, we're going to be evaluating this scary looking trig sum. So it's the sum of the seventh powers of the cosines of 2 pi over 7, 4 pi over 7, and 6 pi over 7. So actually it's not that bad once you use the fact that e to the I theta equals cosine theta plus I sine theta. So if we replace theta with minus theta, we get e to the minus theta equals cosine theta minus I sine theta. We get cosine theta equals e to the I theta plus e to the minus I theta all over 2. Okay, and this ends up being the key to the whole problem. So if we let, say, zeta be e to the 2 pi I over 7, then the sum we want is, well, we first have zeta plus zeta inverse over 2. That's the cosine of 2 pi over 7, all to the 7th. And then we do the same thing for zeta squared and zeta cubed. Okay, now we can pull out a factor of 1 over 2 to the 7th. And, well, this next bit looks scary, but the important fact here is that if you sum all the 7th roots of unity, so 1 e to the 2 pi I over 7 all the way around, you get exactly 0. And if you take any powers of the 7th roots of unity other than the 7th powers, or the 14, and so on, you get 0. So, for example, the sum of zeta to the 9k for k going from 0 to 6 is 0, because taking the 9th powers just permutes these roots around. So again, you're adding up the 7th roots of unity, and that's exactly 0. So when you do this expansion, you'll have, from the first term, using the binomial theorem, we got zeta to the 7th plus 7 zeta to the 5th plus 7 choose 2, that's 21, zeta cubed, plus 7 choose 3 is 35, zeta plus, now I have 35 zeta inverse, and then 21 zeta to the minus 3 plus 7 zeta to the minus 5 plus zeta to the minus 7. Now this looks really gross, and well, it is, but zeta to the 7 and zeta to the minus 7 are each 1, so that's not too bad. And then for the other terms, for example, 7 zeta to the 5th and 7 zeta to the minus 5, I'm going to get something symmetric from the other 7th powers as well. So what I'll end up with is actually 7 times all the 7th roots of unity, except for 1. I'm not going to get any 1s in these terms. And something similar happens with these terms. I get 21 times the sum of everything other than 1, and 35 times the sum of everything other than 1. So in the end, the zeta to the 7ths and zeta to the minus 7s, I'm going to have 6 1s from those. And then I'm going to have 7 plus 21 plus 35, which is 63, times all the 7th roots of unity except for 1. And now all the 7th roots of unity add up to 0. So if I exclude 1, my sum is minus 1. So I get 6 minus 63, that's negative 57 all over 128. And similar tricks can be used to evaluate lots of other trig sums as well by writing them in terms of roots of unity.